Hi everyone, I'm Jing Xing Lim, a final year PhD student from Singapore University of Technology and Design. Today the title of my talk is A Blockchain-Based Approach for Collaborative Formalization of Mathematics and Programs. This video presentation is done for the 4th IEEE International Conference on Blockchain. This is a joint work with Barnabé Monnot from Ethereum Foundation, Shaowei Lin, and Georgios Piliouras from Singapore University of Technology and Design. So we will begin with what is formalization of mathematics and programs. Simply saying, formalization of mathematics and programs is the process of turning pen and paper proof to machine-readable proof code. We will use the famous four-color theorem to illustrate. So on the left-hand side, we have the traditional pen and paper proof, which is written in natural language. Whereas on the right-hand side, we have machine-readable proof code. We call them formal proofs, which is written using through the use of proof assistance. Although both requires a lot of effort in producing them, using formal proof has an advantage in terms of the time and effort used to verify them. So for the pen and paper proof, it requires mathematician or specific field to verify the 140 pages of proofs manually. However, whenever we have formal proofs, the 130 proof codes can be formally, automatically, and almost immediately verified by the proof assistant itself. Other than having proofs automatically verified by machine, proof assistant allows user to leave partial proofs, which mean proofs with gap. So as a result, these gaps, unproven lemmas in this proof, can be used for future continuation from other user or the user itself. This allows collaboration between users. Furthermore, automated AI system tools can be used to partially automate these proof searches as well. So not only human can contribute, AI system, AI tools can be used as well. And lastly, just now in the example, what we have shown is the formalization of mathematics. However, proof assistant can be used to prove and verify software, computer programs, and blockchain protocols as well. So in the recent update in formalized mathematics, Quantum Magazine has an article stating that proof assistant makes jump in big league math. So mathematicians use a proof assistant to verify the accuracy of a difficult theorem at the cutting edge research mathematics. So initially it was thought that it would take up to 2 years to complete the whole formalization. But within a short period of 6 months, the whole formalization is complete. And how is this possible? So there's two factors that eventually contributing to that. First is the sharing of problems and progresses through social media platform. So in their case, they use Zulip, and eventually it's a big collaboration within the community itself. So this brings us to two important key points. To have a platform where user can see the most recent updates in terms of problems, in terms of progresses ASAP, and to incentivize and allocate rewards, if there's any, fairly among the collaborators. Our proposed solution is to blockchain your own partial proof, where there will be some prover or client that state his problem statement, and there will be a cloud of provers to come in and work collaboratively through partial proofs to complete common problems together, or to solve common problems together. Not only that, we would like to extend this idea to include AI system as well. So the AI system can come in and aid us, and as a result, having human and AI collaboration. As blockchain provides features such as decentralization and timestamp verification, there are prior projects such as QDDAS, MathCoin, and ProofGo that discuss the idea of implementing blockchain system for formalizing mathematics. However, what differentiates our paper from theirs is that we discuss the idea of using the use of smart contracts to implement an incentive mechanism, the use of Token-Curated Registries (TCR) to filter submission, and lastly, the involvement of AI systems. So, in the next few minutes, I will briefly explain the overview of our system architecture layer by layer. So it comprises of three interconnected layers. First, the data layer which tells us what to be recorded. Next, the client layer, which tells us what to be presented to the client. And lastly, the incentive layer that tells us what to be rewarded. So first, in the data layer, be it a human or AI system prover that produce the formal proof, this formal proof will be stored in the decentralized file storage system, IPFS, to obtain a hash address. Together with the hash address and the necessary metadata such as whether is it a conjecture, whether is it a partial proof, whether is it a new definition, it will be recorded in the smart contract, and we call this the contribution registry. And eventually this will be recorded in the blockchain itself. So in the current practice, there is a standard library for each proof assistant where the community can refer to. There will be some expert in each community to filter submitted work to be included in the respective standard library. However, in our decentralized system, there will not be any expert as per se to do this. Thus, having a token-curated registry contract or some form of voting mechanism that can allow all users to vote and decide if a particular proof should be included in the standard library. And we shall call this the canonical registry. So when the formal proof file has been decided to be included in the canonical registry, it can be either a completed object or partial contribution to a bigger proof. So for completed object, the user can set the right of use, whether is it free to use, whether is it restricted to use, or is it you need to pay some amount just to use it to import the file. So for partial contribution of a bigger proof, a proof assistant plugin can be so-called installed such that any user can see the current progress of the new proof that has come in, and the string diagram of contribution will show the linkage between the prior imports and the future subsequent imports that will eventually link all the proof together. So for client or any other user can write a smart contract to trigger incentive mechanism once the proof has been completed. So appropriate token distribution from the incentive mechanism will be triggered once the whole proof has been completed. To better understand our system architecture, we will illustrate using an example on how a sort program can be formalized in Cork, the proof assistant. Suppose there is some client that posts an output problem statement asking for proofs of a sorting program specification. So over here is seen over here as a conjecture sort proc. So it states that for all L lists, there exists an L prime list such that is sorted and is a permutation of our original list. And this file we name it as CT00. Okay, so as the client or human prover produce this formal proof, it will be stored in IPFS and obtain the hash address. So as mentioned previously, together with the hash address, okay, the necessary metadata such as the file type, so for this case it's a conjecture, okay, the imports and all other necessary metadata will be recorded as a contribution registry as shown here as an example and recorded in the blockchain. So after that, you go through the TCL contract, the voting from all the user whether to be included in a canonical registry. As this is a partial contribution, or to be more exact, is initial contribution. Okay, a string diagram will be presented to all users to show the current progress. Where is it at? So in this case, we will use the age to represent the type, which means the problem statement, the theorem statement, node to represent the proof of the theorem that, or partial proof of the theorem that they try to solve. So for solid circle represent the completed partial proof, and dotted circle will represent the incomplete proof, partial proof itself. As the client is asking for proof, so it can so-called write incentive contract such that it will trigger certain incentive mechanism once the proof has been completed. So this is an example of how this incentive mechanism or incentive contract can look like. Contribution can come from human or AI system. Here we will look at how a human contribution will look like. So in this case, some prover, we call it prover A, has written a Cork file called CT01. So in this file, we make a reference to CT00, which is the code that posted the original sorting program conjecture. So over here, he make a partial proof Okay, so we believe that by using induction, okay, you can continue to proceed with the proof. So there's two unproven lemma that left as gap. So it's called sort base and sort prop IH. So inductive case as gaps for future completion. So as similar as before, this contribution will be recorded. A contribution registry contract is written and recorded. So in this case, instead of conjecture, it's a partial proof. Okay, and pass through the TCR and to be voted in as canonical registry, same as before. However, what is important is in the client interface, okay, as the sync diagram as we've seen previously, okay, after this CT01 has been posted in the system itself, we're gonna see changes and update to this string diagram. So this is the update that you will see. Okay, after this partial contribution of CT01, it has broken down this problem of sort prop into two smaller problems, sort base and sort prop IH for future completion. So here is so-called the completed subproof, okay, or completed partial proof will lead to two smaller dotted circle which represent two smaller proof to be completed for in the future. After which, here is an example of how AI system can come in to help in automating the proof searches. So suppose a node or user is implementing Cockhammer, an automated reasoning tool for Coq. So it tries to automate the proof for all the conjecture up to this point. So up to this point, there's three conjecture up there. So there's sort prop, which is the original problem, sort base, and sort prop IH, which represent the inductive case. So you try to automate each one of them. Okay, so the first one failed, the second one passed, and the third one failed. So in the client interface, after CT02 from this AI Cockhammer has been produced, we're going to see an update in the string diagram representation. So this is what we have seen previously after CT01. So after CT02 has been presented, okay, we will see that, oh, there's an update in it, and the sort base proof has been completed through the partial proof or disproof contribution of CT02. By the way, I will use green node to represent AI system contribution. As the process goes on, eventually all the partial proof are completed and string together as a completed proof. Over here, we can see that the proof of an insertion sort is completed through the collaboration of both human and AI system. So once this is achieved, the incentive mechanism, the incentive contract will be activated and distribute the rewards accordingly to each contributor based on some weights predefined in the contract itself. As we know that there are more than one way of proving a theorem, there are certainly more than one way of sorting a list, such as insertion sort, merge sort, and quick sort. So, incentive mechanism can be implemented so that provers are incentivized and rewarded accordingly based on some weights predefined in the mechanism itself for producing different proofs. Thus, provers can be rewarded not only within the same proof, but across different proofs. To conclude, the challenge is to gamify the formalization of mathematics and programs through incentivizing collaboration between humans and AI systems. Our proposed solution is to use blockchain as a platform to unite collaborators, be it humans or AI systems. With the ever-improving AI system, we hope that one day one could just state a problem statement, post it on the system itself, and different AI systems can come in and work together to solve the problem, working as a unified proof or program synthesizer. There are two future directions we are working on. One is the game theoretical analysis on how we can allocate rewards fairly to contributors, not only within the same proof, but across different proofs, as mentioned in our example previously. And the prototype that with some basic functionalities. With that, thank you for listening. If you are interested in my work, or if you are looking for someone in the direction of blockchain or formal proofs, please feel free to contact me. Thank you.